Hi, fifth grade families. Welcome back to another Home Connections tutorial video. Today's video is going to be on Unit 2, Module 3, Session 5, or if you go by the page numbers, that's going to be page 35 and 36. Okay. I had a request to just kind of go over what we're doing in general before jumping into the homework. So I'm going to go over the 4 different strategies that we have learned at this point to add and subtract unlike fractions. I'm going to do 4 problems with the different strategies. Then I'm going to jump in and do one problem from problem 1 with you, and then set you up or explain the rest of the problems in the home link and let you do the other problems on your own with having me set it up. All right. So one of the models that we have worked with is the clock model. Now I don't have an actual picture of the model, but if you are in Ms. Carter's class, I sent to your parents a PDF of all these models, so they should have those little clock models on that as well. So in my class, we talked about when to use a clock model. Some of the fractions that tell us when to use a clock model would be halves, thirds, fourths, sixths, twelfths, and then sixtieths. Okay. The biggest thing to remember is that you can either use the clock model to do minutes, which would be 60. Let me change my color really quick. We have 60 minutes total in an hour. Or we can think about doing hours. So we have that 12 hours on a clock. Sorry, I should have put minutes here. Okay. So if I have 1/3 plus 1/4, I need to find some equivalent fractions that are equivalent to 1/3 and 1/4 because I cannot add these together as they are since they have different or unlike denominators. So we have to find a common denominator. Now with the clock model, we can do this by having a denominator of 60 by thinking about it in minutes, or a denominator of 12 by thinking about it in hours. So let's go ahead and start with minutes. I'm going to do my minutes in purple. So again, it's 1/3 plus 1/4. So if I think about my clock, I have to think about, well, how many minutes out of 60 would 1/3 of my clock be? And it's actually 20 minutes out of 60. So my equivalent fraction to 1/3 is 20/60ths. Then I have to think about, okay, if I imagined 1/4 or if I colored in 1/4 on my clock model, how many minutes would that be? And that would be 15 minutes out of 60 total. So now I have my equivalent fractions. So again, 20/60ths is equivalent to 1/3, and 15/60ths is equivalent to 1/4. Now that my fractions, my equivalent fractions, have a common denominator, I can go ahead and add them, keeping that denominator the same, adding my numerators. 20 plus 15 is 35/60ths. I can also imagine or even draw. I'm going to do red for hours. And when I say draw, I'm thinking about that clock model that we worked with in class. So if I had the clock model and I split it up into thirds and split it up into fourths, thinking about if I had this much shaded in on our clock, how many minutes and hours would that be? So if I thought about it with my hours, if I had 1/3, how many hours would that be? That would be 4 out of 12 hours. 1/4, if I picture again or draw that 1/4 on my clock model, that shows that it's covering up 3 out of 12 hours. So now I have my equivalent fractions. 1/3 is equivalent to 4/12. 1/4 is equivalent to 3/12. Now I can go ahead and add those together, keeping my denominator the same, adding my numerators. Now, even though I have two different answers from when I did it in minutes and hours, I have 35/60ths for minutes and 7/12 for hours. These are also equivalent as answers. Okay, so that's the clock model. Moving on to the money model. Again, in my class, we talked about when some of the fractions we could use for the money model would be halves, fourths, fifths, tenths, 20ths, and hundredths. So our equation for this one is 1/4 plus 1/2. Now I want you to think about it as change. How much change is in a full dollar? We have 100 cents. Okay, so if we're thinking about we have a whole dollar, then what is 1/4 of a whole dollar in cents? We know that quarters are 25 cents out of a total 100 gives us that 1/4 of a dollar. So 1/4 is equivalent to 25 hundredths. Then we have to think about, okay, what's half of a dollar in change? I know that half of a dollar is 50 cents out of a total 100. So again, my equivalent fraction, 1/4 and 25 hundredths is equivalent. 1/2 is equivalent to 51 hundredths. Just thought about 1/4 of a dollar is 25 cents. Half of a dollar is 50 cents. Then I can go ahead and add these together to get 75 hundredths. I could also think about, I know 75 cents is just 3/4 out of 4. Okay, now we're going to move on to our ratio table. In my class, we talked about if the money model and the clock model are a bit confusing to you, or because maybe you don't use change or you're not using an analog clock, they might be confusing, that you might want to use a ratio table. All right, so I put 1/6. Sorry, I'm actually going to back up. All right, so using the ratio table, like I just said, these are unlike, we need to find a common denominator. So when we're thinking about common denominators, we want to find common multiples between 6 and 4. And when I say multiples, think about that like you're skip counting. So your multiples of 6 would be 6, 12, 18, 24, and so on. Multiples of 4 would be 4, 8, 12, 16, 20, 24, and so on. So these are the multiples that we want to find, and we want to find ones that they have in common. So between 6 and 4, they have 12 as a common multiple and 24 as a common multiple. So we could use either one of those. We're going to use 12 for this one. So I'm going to find an equivalent fraction for both 1/6 and 2/4 that has the denominator of 12. So I'm going to first start with 1/6. Oops. So I'm going to write 1/6 into my ratio table. I already know that 12 is going to be my common denominator. So I'm going to write 12 on the denominator side. Now I have to think about, well, how did I get from 6 to 12 by multiplying? I multiplied by 2. Now whatever I do to the bottom, I got to do to the top. So if I multiply by 2 on the bottom, I have to multiply by 2 at the top as well. And 1 times 2 is 2. So our equivalent fraction to 1/6 is 2/12. Okay, now we need an equivalent fraction for 2/4. In my class, sometimes we have made another ratio table. Sometimes I've just put it on the same one. Whatever floats your boat in this case. For the sake of this video, I'm just going to make another one. So we have 2/4. We've already determined that our common denominator is 12. So then I have to think, well, how did I get that denominator? By multiplying. So 4 times 3 is 12. Whatever I do to the bottom, got to do to the top. So 2 times 3 is 6. So that means 6/12 is equivalent to 2/4. Okay, so I know it was a lot, lots of steps. Just to recap, we started off here. We found equivalent fractions so that we could add them together. So 1/6 is equivalent to 2/12. We did that right here. 2/4 is equivalent to 6/12, which we did right here. Now that they have a common denominator, we can go ahead and add them together. 2/12 plus 6/12 is 8/12. So that would be the ratio table. And then finally, we have the double number line. Double number line you could also use with any fraction. So I have 1/2 plus 2/8. Thinking again about what could be a common multiple between 2 and 8. 8 could be 1, 16 could be 1, 24 could be 1. For the sake of this video, let's go ahead and do 16. So on the top number line, I'm going to do my fractions. On the bottom, I'm going to do whole number. This is kind of like our trail problem. We were working on maybe last week, if you're in a different class, maybe a week before, maybe I haven't gotten to it yet. So I'm going to do 16 as my whole, and this is going to be 16 out of 16. The only thing about the double number line is you have to remember doing fractions of. So I'm going to do 1/2. That was a bad halfway. There's my 1/2. Okay. And then I need to think about, okay, well, what's 1/2 of 16? Whenever we do a fraction of, that means we're multiplying. So this becomes 16/2, or 16 divided by 2 is 8. So 1/2 of 16 is 8. And then I need to do plus that 2/8 to see where I end up here. So I have to think about, okay, what's 2/8 of 16? In order to do that, I'm going to do 1/8 of 16, or 1/8 times 16, which gets me 16/8, or 16 divided by 8, which is 2. So if 1/8 of 16 is 2, then 2/8 of 16 would be 4, because I have 2 of those. So it means I'm adding 4 right here. 8 plus 4 is 12, which means I get 12/16. You know, that one is also involves a lot of steps. Personally, my favorite would be the ratio table. All right, now that you have seen all the 4 different ways, let's go ahead and jump into your homework. All right, jumping into your homework, let's go ahead and work on problem B. So problem B, we have 7/9 minus 4/7. Now, if we think about all of our different models, thinking about what we could use, I don't think the clock or money model would be best to work with 9ths and 7ths. In my personal preference, I think a ratio table is tried and true. You can use this for any fraction. So let's go ahead and use that. So we have to think about what's a common multiple or common denominator between a 9 and 7. You could always multiply these together to get it the fastest if you're not really feeling very confident in your multiples. So 9 times 7 is 63. So my common denominator for this problem is going to be 63. So I'm going to start with my 7/9. Sorry, I don't know what's going on with my iPad right now. There we go. Okay, go ahead and write that down if you haven't already. Then our denominator is 63, so we're going to put that denominator down. Then I need to think about, well, what did I do to get from 9 to 63 by multiplying? We did times 7. Whatever I do to the bottom, I got to do to the top. So I'm also going to multiply by 7. 7 times 7 is 49. So my equivalent fraction to 7/9 is 49/63. Very interesting fraction, I guess I'll say. I'm actually going to write that down here. So I have 49/63. So now I need to find an equivalent fraction with a denominator of 63 for 4/7. So I'm writing down 4/7. Go ahead and set that up. All right, then our common denominator, as you know, is 63. So then thinking about how did I get from 7 to 63, I multiplied by 9. Whatever I do to the bottom, have to do to the top. And 4 times 7 is 28. So 28/63 is our equivalent fraction to 4/7. Now that I have a common denominator, I can go ahead and add those together, keeping my denominator the same, adding my numerators. 49 plus 28 is 77. We've talked about in class putting this in this improper fraction. So remember, this is an improper fraction because our numerator is greater than our denominator. We could also make it into a mixed number. So I know that 63 goes into 77. I'm going to move this over really quick to show you that it's equivalent. 63 can go into 77 one time with 14 left over. So this would be our answer. Now, if you're doing this with me, you shouldn't be just writing down the answers, but also the work. All right. I'm going to go over the rest of the homework, but you are doing it on your own. So looking at A, we have 5/14 plus 4/5. So my denominator is 14ths and fifths. Having to think about what could be a common denominator that would work. Maybe just go ahead and multiply 14 and 5 together to get that common multiple. Okay. Then on this one, we have blank plus 1 1/3 equals 2 5/12. So we have to think about what we could add to this to get that. I think the best way to do this would actually to flip it around. So you might want to do 2 5/12 minus 1 1/3, because that's going to get you what you could add to 1 1/3 to get 2 5/12. All right, so looking at D, and I apologize if you can hear some students out in the hallway, but we have 2 1/3 minus blank equals 11/15. So we have to think about what can we subtract from 2 1/3 in order to get this. The same way on C, where instead of adding, we have to subtract them. On this one, instead of subtracting, we're going to go ahead and add these two together. So I would add 2 1/3 plus 11/15 to get what would go inside this blank. All right, looking at number 2. George and his dad made some snack mix for their camping trip. To make it, they used 2 cups of mini pretzels, 3/4 cups of peanuts, and 2/3 cup of dried fruits. Our question is, how many cups of snack mix did they have when they were finished? Show your thinking. So they're adding all together in this huge, big snack mix bowl. Let's say here's their snack mix. They have 2 cups of pretzels going here, 3/4 cups of peanuts, and then 2/3 cups of dried fruit. So all of this is going into that snack mix. So to figure out how many cups, I want you to think, well, if all of this is going into there, would we be adding and subtracting? Okay, so then coming up with your equation, you're adding 3 numbers together. Sorry, I just gave it to you. You're adding these together. So go ahead and add 2 cups plus 3/4 plus 2/3. So I should see that equation somewhere in this space. Maybe some ratio tables. Maybe you're thinking about clocks to do this. Maybe you're thinking about the money model to do this. But I should see either clocks, minutes, hours, money models with change in cents, maybe the ratio tables, or maybe even the double number line. So make sure you're showing all of your work in the space to do so. If you need to at any point, go back at this in this video and see how to use one of those strategies. Go ahead and rewatch it before you do problem number 2. All right, problem number 3. Lisa drank 7/16 of a bottle of water during the soccer game. Julianne drank 2/3 of a bottle of water that was the same size as Lisa's. We are asking who drank more and by how much. Show your thinking. So if we're trying to find the difference between 2 people and how much they drank, thinking about what operation it might be, adding, subtracting, multiplying, or dividing, if we're finding the difference. Think really quick. Okay, if we're finding the difference, that means we are subtracting. And then you also have to compare who drank more. Now, finding a common denominator is going to help you compare by who drank more. So I should see on your papers, after you do all your work, maybe blank, either Lisa or Julianne drank more water by however much. Yeah, so by however much goes in that blank. Okay. Again, you're subtracting. You're going to need some common denominators to solve for this. All right, as usual, in my class, I cannot speak for any other classes that are watching this video. The challenge is optional and is completely done independently. Good luck.